Hello and welcome back. Today we're going to be talking about Newton's first law. I'm sure you've heard of Newton's laws before. It's a fundamental of all physics. Newton's first law is also called the law of inertia. If you go on Google, you can find the definition of Newton's first law to be: if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line unless it is acted upon by a force. Now, if you're like me, then the first time hearing this, you probably have no idea what this means. It's all a bunch of nonsense, gibberish physics talk that just simply doesn't make any sense. So let's try and parse through this to make it make sense. If I were to summarize Newton's first law, it just means that without a force imbalance on an object, the object will continue its state of motion, which could be rest. Let's say a ball is just sitting on the floor. What forces are acting on this ball right now? Well, we've got the force of gravity, which is pointing down. And then we have something called the normal force, which is the ground pushing up on the ball. And these are equal in magnitude, otherwise the ball would be moving up or tunneling into the ground. Now, this ball is at rest, and according to the law of inertia, this ball will continue to be at rest until a force acts on it. Now, that should make a lot of sense. If we have this ball sitting on the ground, unless we kick it or push it or throw something at it or whatever, that ball is not going to move. Now, what about a car? My lovely car drawing. And it's moving at a constant speed to the right of 10 meters per second. Now, in reality, there is a lot more that goes into the forces of wheels and cars, but for Physics 1, once again we have the force of gravity and the normal force acting upon the car. And if you were to add those normal forces and the force of gravity, you're going to get 0. Because there's no force that is acting upon the object, which is the car in this instant, to make it unbalanced, this car is going to remain moving at a constant velocity in this straight line. Pretty cool. Now, I mentioned adding up the force of gravity plus the force normal to make 0. Well, there's a term for adding up all of those forces, and that's called the net force. That is a huge term that you're going to want to remember. It means the sum of all forces acting on an object. So if we go back to the ball in the car, the net force equals 0, which means it's going to stay at rest. And for the car, the net force is also 0, which means it's going to keep going in that state of motion that it's already in. Oftentimes, the net force is simply depicted as F. You can also see it sometimes depicted as summation F. Let's go back to that ball. Make a new drawing. We've got the force of gravity going down, and the force normal going up, and they are equal magnitudes. So as of now, net force equals 0. And by the law of inertia, this ball is going to remain at rest unless a force unbalances that net force. So let's say it does. Let's say I walk up to this ball and kick it. My kick is going to add a force on the ball, let's say directly to the right. Well, now what? Our forces are no longer balanced. Our net force is no longer 0. Let's call the force of my kick F subscript K. So the net force equation, no longer 0, F is going to be equal to Fg plus Fn plus Fk. And just by looking at the drawing, you can see that Fg and Fn are going to cancel out to be 0, which means F, or net force, is Fk. Now, due to Newton's first law, because there's an unbalanced force, this ball is no longer going to remain at rest. If I were to summarize all of this into a single sentence, it would be, if there is no net force, meaning net force is 0, there is no change in velocity. This is an extremely important concept to understand. Now, you won't have to worry about this for a while in Physics 1, but you will eventually. But that property of resisting change of motion in an object is called inertia. It's also why Newton's first law is called the law of inertia. Alright, that's it for Newton's first law. Stay tuned for Newton's second.